I first started working at NASA in 2007, a lot of people, they just didn't even realize that NASA studies Earth. And I think now probably you already know that, but I'm going to emphasize it. There's Earth, and you can see that, maybe we shouldn't have called it Earth. Maybe we should have called the planet ocean because it's covered by 70% water. And one thing that people don't know is how many Earth orbiting satellites we have. So this is the fleet. It's either 19 or 20, depending on how you count, satellites that orbit our planet, looking at our Earth. And these are all NASA satellites. So people often, I give a lot of lectures and a lot of talks, and people often they ask me, well, what's the difference between I thought there were thousands of satellites. So these are NASA satellites that you're looking at right now. Again, I said there's about 20 of them. And what that means is that NASA only does one of a kind, handmade, unique experimental instruments. So that's not like a telecom satellite or a GPS satellite or a satellite phone. These are, again, one of a kind instruments, and many of them study Earth's ocean. And we're going to look at some of them more in depth. And again, I've seen about 5 of these guys launch, and they're pretty cool. I've seen many of them actually being built. So we're going to take a look at that now. And just when I say there are satellites, I don't mean that they're my personal Laura's satellites. I mean that they're all of our satellites. They belong to us. Okay, so before I go on further, I just want to say that we can stay connected after this teleconference. So we have a Facebook page, NASA Climate Change, and we're just under 1 million followers. So maybe you guys can push us over the 1 million mark. There's our Twitter handle, and I actually have my own personal Twitter. I have a blog, and then there's free apps that you can download. One is called Earth Now, and the other is Earth Images. So I'm just going to leave this up for a couple of seconds. This is, again, just a way for us to stay connected after this webinar is over. So I want to jot this down for 2 seconds. All right, moving on. Maybe I'll put that up at the end. So this is where I work, Jet Propulsion Laboratory. It's in Pasadena, so it's big, this whole area. And this is Mission Control. So the satellites are run from NASA Mission Control. You may have seen it in The Martian, but that's what it looks like, a photo of it. And here's the website that I'm the senior science editor of. It's called NASA's Global Climate Change, and I'm going to show you it here also. So this is the most recent blog, and come on, you can see it's beautiful. Okay, and going back to the slides. And this is a oceanography satellite that launched. So one of the things that the satellites can do that you can't do from ground is you can study the entire ocean. So this satellite, it's called the Ocean Surface Topography Mission, and sometimes they call it JASON also. It looks at sea surface height all around the world all at the same time. So you can see sea level rise in a way that you couldn't just see from the ground. And our oceans have been rising due to climate change. And again, that's what it looks like. This is a photo that I took of an instrument being built in the lab. So this instrument looks at soil moisture, and that's the antenna all stretched out. This thing is the antenna. And you can see it's gold color. And the reason that it's gold color is that it's actually made of gold. And there's scientists and engineers working around to create this stuff. I'm just kind of showing you what I do for a living. So here I am. This is Buzz Aldrin. He's an astronaut. There's the app. Here's the satellite being launched. Here's me talking to an engineer who's working on building satellites. And this is a photo of a bunch of kids who came to visit the lab. And the reason that I put this on here, I'll tell you a little story about what happened when these kids came to the lab. So they were extremely well behaved, okay? And you can see how beautiful they're in the museum at NASA's Jet Propulsion Laboratory looking at the Mars rover in this picture. The museum's really cool. Anyway, so these kids are super well behaved and they're having different people give them talks and presentations. And it's my turn to give them a talk and a presentation. And they were so well behaved that I decided to kind of rile them up a little bit because, a field trip's supposed to be fun, right? So I say to them, who likes Justin Bieber? And about half of them are like, yay. And the other half are like, boo. And so then I said, who wants to be a scientist when you grow up? And it was all of a sudden super quiet and nobody said anything. And then finally, this one little kid in the front, these are third graders, this one kid in the front, he says to me, I'm not smart enough to be a scientist. And then I said to the rest, and I kind of puffed up and I said, who told you that? And he said, I thought it in my own head. And then I asked the whole rest of the group, what do you think? And how many of you think you're not smart enough? And about three-quarters of the room lifted their hands thinking they're not smart enough. So this is what I wanted to talk to you about. All right, you are smart enough. And anybody who tells you, or if you thought it in your own head, it's just not true. And I guess that's one of the things that I showed you this slide where it's like I'm doing all this stuff and I sound really cool and I work at NASA and I create apps and I go to launches and I sit next to, super famous astronauts. But the truth is that the most important thing I do, and I'm not, lying or just placating you right now. The most important thing I do is interact with students and people like you to tell you that you are enough. And I'm going to tell you that every day, all day. And the thing is that the truth is, and no matter how many of these different webinars you attend, you're going to hear that there's some pretty negative stuff going on our planet. There's a lot of ocean pollution, sea levels rising. We're facing climate change. We're facing all these really difficult challenges. And, the younger generation is going to have to face them more than my generation does because all of this is increasing. There's more humans on the planet and less biodiversity. But you have to believe that instead of, oh, it's so negative, it's like, oh, it's amazing challenge. So when you face an exam in school, right, instead of thinking, oh my gosh, this test is so hard, think, oh my God, I can handle this really hard challenge because really hard challenges are exciting and they force us to grow. And I just need to emphasize that again and again and again and again. You think at NASA that we sit there and go, oh my gosh, we can't face a challenge. You know how hard it is to create these instruments? Let me show this to you again. To create this instrument, this is a giant antenna that's like 30 feet across, right? And it spins around in space and goes on an instrument. It was a huge challenge to create. You think this is easy to build a satellite and launch it into space? No, it's a huge challenge. And we've had enormous failures at NASA. Sometimes they just blow up, sometimes they land in the ocean. I saw one explode on the launch pad. I mean, it happens. And we don't just stop what we're doing when we fail. Failure is part of success. And I want you guys to learn that right away. So every scientist has to go through failure. Every scientist has to learn in order to grow. And don't ever tell yourself that you can't do it. Tell yourself that failure is okay and you're going to keep moving through it no matter what it is. There's no successful person got A's on every single test. No successful person didn't face challenges. And I hope that you welcome these challenges because your generation is going to, look forward to growing through a lot of this stuff. So I guess that's the biggest thing I want to tell you before we start into like more of the heavier science. So here we go. All right, Earth. We're facing a lot of problems. So one of the things we do at NASA is we look at the whole entire planet. And I'm going to show you some data sets from planet Earth as a whole. We look at carbon dioxide from space. We look at Earth's temperature from space. We look at sea level rise from space. And we look at ice mass loss from space. So we're going to go ahead and look at a few of those things. But before we go into it, we also see how gorgeous the Earth is from space. So you want to appreciate Earth before we damage it. And here's some more. Just gorgeous, gorgeous. These are not touched up. These are not Photoshopped. This is random question. In the news I read China sent a rover for the first time to the moon. Are they where we were when we first did, or are they using advanced tech? Well, I mean, every every country has, not every country, many countries have their own space program. I'm not an expert on China's space program, so it's hard for me to answer that. Um, you know, I believe that every country who's sending up missions right now is trying to do, something new and innovative. And a lot of the instruments, like this one right here that I showed you before, this is a collaboration between the French Space Agency, the European Space Agency, the America's NASA, as well as the National Oceanic and Atmospheric Association, so NOAA. So a lot of times scientists collaborate. In fact, science is one of the most collaborative fields in the world. I think a lot of times you see a single scientist and there's a stereotype that scientists are loners, but scientists work together all the time. Space station is international and there's scientists from all over the world up there. Okay, sorry if I didn't answer that perfectly. Okay, so the Earth is beautiful. This is what mountains look like from space. You can see the tops of the mountains have snow on them, and then the valleys don't. Super beautiful. I just wanted to show you some pretty stuff before we get into, climate change and sea level rise is kind of a huge bummer. And that's why I gave you that little pep talk to say when something really gets in your face and is super negative, don't look away, don't go into denial, face it with power, strength, and confidence. And that's what we're going to do right now. So I'm just going to talk to you for a few minutes about climate change. And this is what we study from space. We have seen that humans are burning fossil fuels. So a fossil fuel is coal, oil, or gas. And when we burn them, it releases carbon dioxide into Earth's atmosphere. And so since the Industrial Revolution, since humans have started burning fossil fuels, carbon dioxide has gone up. And here's another view of it. So up and down and up and down. This is the natural going up and down of carbon dioxide in Earth's atmosphere. And then here's where it is today. So, although you've maybe heard carbon dioxide have changed in the past, it has changed in the past, but now it's just ridiculously high, for one thing. And for two, it's going high really, really quickly. So this is the negative thing that I was telling you that your generation is going to have to face even more than my generation is, okay, what are we going to do about this? And denying it and looking away and feeling like helpless isn't the solution. So the solution we're going to talk about in a minute. But, I just want you to feel your own confidence and your own power. And then this is a video. So I want to show you this video. This and play. So it shows you carbon dioxide.
Oh, this is Bill Buckman. I'm a climate scientist at NASA's Goddard Space Flight Center. What you're looking at is a supercomputer model of carbon dioxide levels in the Earth's atmosphere.
All right, I don't want to hear that guy talk.
The visualization compresses 1 year of data into a few minutes.
This data. So this is the type of data.
Carbon dioxide is the most important greenhouse gas affected by human activity.
Are these, okay, so I'm just reading a question. Are these changes going to start another stage of the Earth, such as right now we are in the green stage, we will reach another black stage? I'm not sure what you mean, a green stage or a black stage. I'm not, you said right now we're in the green stage. I've never heard of the green stage. So that's one of the things that scientists are studying. So there's certain things we know and there's certain things we don't know. So one of the things that we know is that humans are causing climate change. One of the things that we're studying is how fast are things going to change, and is there going to be a tipping point? So does this mean there will be another ice age? So eventually on planet Earth, we go through cycles and there's going to be another ice age, but right now we're in a huge warming phase. So the latest studies are how fast are we warming and what's going to happen when we warm even more and more and more. So we know the ice is melting and we know sea levels rising and we know carbon dioxide is increasing. The thing that we don't know is what are humans going to do about it? Are we going to change? Are we going to get off fossil fuels? I mean, humans are a big player in this. So if humans change and if we get off fossil fuels, we might raise the temperature a little bit less. So we're in this for the long run. We are raising the temperature. Sea levels are rising. Ice caps are melting. But the question is how fast? And a lot of the answer depends on what we do about it today and in the future. Okay, it's the seventh stage of Earth, while the black stage is when the Earth was in a polluted stage with dead and decline. Yeah, I've never heard of this black stage. I'm sorry, and I've never heard of the seventh stage. You might be talking about extinction cycles. I'm not totally sure. And you're saying the Earth was polluted state with dead. So I mean, every winter and there's summer, spring, vegetation dies off and then it grows back in the spring. So everything's continually cycling. Is the space elevator a real thing? All right, so I'm gonna just go through this one more time so you guys can see it.
This is Bill Putman. This is Bill Putman. I'm a climate scientist at NASA's Goddard Space Flight Center.
And then I'm going to go back to the slides. Okay, I'm going to try to answer some of the questions, but if I try to answer all of them, we'll be here all day. And I've given you my information so you can contact me after. Okay. So we raised global, I told you that carbon dioxide levels have changed. So what carbon dioxide does is carbon dioxide reacts with temperature and it causes Earth's temperature to rise. So here you can see Earth's temperature rising. And that's because of the carbon dioxide. So the carbon dioxide stays in Earth's atmosphere a really long time, and you can see global temperature rising. So I want to go to the co-browser again for a second. And here's our website that I was showing you before. And then I'm going to open this. There we go. So you can see since the Industrial Revolution, I'm going to go over this, since humans have been putting carbon dioxide into the atmosphere, the temperature has been rising, and this is now. So it's that much over average. And I just want to slide this slowly. This is the website that I write. And you can go there too. You can see it. It's climate.nasa.gov if you want to go there. So here's the Industrial Revolution, and here's planet Earth. Can you see here's South America, here's North America, Africa, Australia, Indonesia, India. You can see the countries behind, right? So I'm just slowly going to drag, and you can see the dates up at the top, 1900, right? And I always like to stop around like 1936, 37, because my house was built here. So this is the temperature on planet Earth when my house was built. And then you can see the red starting to get warmer and warmer. Oh, where did it go? What just happened? Oh, here it is. You can see the red starting to get warmer and warmer and warmer. And actually, I was born around here. And then I'm slowly dragging it. And here's 2005, 2006, 2007. You guys were all born by here. And 2015. So this is the temperature on planet Earth compared to 100 years ago. Or a little over 100 years ago. It's gotten so much warmer.
Having difficulty with the map or that you're referencing, we're just seeing the homepage of the website.
Oh, you're not seeing this?
No.
You're not seeing this? Okay, let me try. I uploaded a video. Let me see if I can find it in the video player. So the reason the video player only shows you up to 2014. Can you see this? Oh, you can see this one. Good. Okay. So this one only shows you up to 2014, and the website is the latest data since last year. So you can see, the temperature rising. That's in the 70s, the 80s, the 90s. Some of you were born in the 2000s, and then all of a sudden it's just red, 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 red. So I can hopefully scrub through this, play it again. So starting 100 years ago, and here's North America, South America, Africa, Australia, Indonesia, and then all of a sudden it starts to get more red and more red. And this is what humans have been doing to our planet. We've been warming it. And perhaps you can even think of times in your life where you've seen the effects of a warmer planet. So there it is. And now you can see if there's a lot of ice around here in Greenland and in the Arctic, well, of course, there's this warmer temperature. Of course, there's going to be more ice. Okay, so we watched that video. So what happens when you warm the planet? You have ice melting. And you can see here the ice is melting, going down. This is the amount of ice starting when the satellite launched. In the 70s, we launched our first ice observing satellite at NASA. And, every winter the ice kind of gets cold and freezes, and every summer it melts a little bit. It goes up and down. That's the natural variation. But if you can see over time, it's going more down. So when the ice melts, guess what? The sea level rises. So I love this photo. One of the things that some of the glaciologists did was that they would find these really, really old photos, and then they would go to the exact same place and take a photo now. And so I had to find these double pairs of ice. And the only way you could tell, see, these mountains in the back are the same. And that's what people used to wear that's the cameras that they used to have in the late 1800s. So really all this ice has now melted and it came into the ocean. So while the ice melted, the sea level rose. Now there's two reasons why sea level rises. One is the ice melts and it falls off the land and into the ocean and sea level rises. And the other thing is heat causes things to expand. You probably already know this from a science class. So the warmer water is also expanded and causes the ocean all around the world to rise. So that satellite that you saw that I showed you launched, there's 4 of them, a series, and they've all been measuring sea level rise since the 70s. So here it is. And sea level has risen about a foot in the last 3 decades. So that's a lot. It could raise a lot more. Okay, so I teach oceanography, and when I first started teaching in like 2000, I would show this map to my students, and they would just kind of be bored. So I'll show it to you now. So this is the coastline during the last ice age, when all the ice or much of the ocean was locked up in the ice caps, right? So when the ocean is in the ice caps, sea level is lower. And if the ice caps melt, sea level rises. So this would be the coastline here if the ice caps all melt. And you can see Florida doesn't even exist, right? In the middle of the country is completely flooded. And people, when I first started to show them this map, they would all be like, yeah, whatever. But now you've seen so much flooding in Florida. You've seen Hurricane Katrina. You've seen all this examples of flooding. And now all of a sudden it's like people aren't rolling their eyes. They're like, this is real. And this is, again, some of the stuff you're going to have to face. This is in California, in a very wealthy part of California, Malibu, near where, not that far from where I live. And you can see all these sandbags. And you can imagine that wealthy people have not put these sandbags there because they're so pretty and they enjoy sandbags. They're there because the ocean is coming up near their houses and trying to protect the homes. I also wanted to show you this photo. This is a photo of Santa Monica Beach, and you could see all this trash, and there's a bird there, and that bird did not put the trash there. People put the trash there. And kind of the reason I put this in here is to just show you that carbon pollution and plastic pollution, I think people sometimes get them confused, and they're not the same, but in a way they're kind of the waste products of our lives. So what we do is when we turn on the light or turn on the computer or drive a car, we don't see with our eyes the carbon dioxide going up into the atmosphere and polluting our world. And when we take a plastic piece of trash and throw it down or throw it out the window, we don't see it, right? And the reason that we're seeing it here is because it's right after a storm. And this is a public beach, and the city workers clean the beach. So if you go on vacation and you're in like a gorgeous resort or something and the beach is clean, it's because somebody woke up early or stayed up late and picked up the trash. If you go to a beach where nobody is there, you will see trash, and a lot of trash. And the correlation is that plastic pollution and carbon pollution, they're the waste products of our lives. That, when the trash collector comes, I don't know that person. They just come and like take the trash and it goes to a landfill far away. Or when I burn fossil fuels, they're burning out of a power plant that I'm not standing next to and I don't see with my eyes. But we are starting to see from satellites, and we're starting to see when we pollute the planet so much again and again and again and again, we can't mistake it. The plastic's like invading us. The carbon dioxide is invading us, and we're starting to see it. So I think I kind of put this slide up here as a wake up call to say, hey, this stuff is real, and to not turn away from it. Remember, half an hour ago, I said to all of you, there's going to be some big challenges in all of our lifetimes that we're going to have to face. And this is one of them. What are we doing with the waste products of our lives? And I really encourage your generation to face it with courage and strength and self-confidence, because all of us need all of you to face this challenge. So there it is, looking at you. That bird again did not throw that trash down there. So I just want to take a moment. I know this is kind of heavy stuff, to step back and look at planet Earth and look at how beautiful it is and look at how amazing it is, and to feel empowered that everything we do has an impact. Nothing is too small. And all of us, I mean, there's supposedly 1,000 people watching this right now. So can you imagine if all of us band together and everything we do has an impact? So I wanted to show you one other video. This is my favorite NASA video of all time. And I'm going to let the audio play because I love it. So this shows the ocean all around planet Earth. We take satellite measurements, and then we can take all those measurements and put them into a model, and it shows you the currents around planet Earth from space. And I think the thing that I love about this is it shows you how beautiful Earth is, and it also shows you how interconnected Earth is. So again, that's my favorite NASA video of all time. It's called Perpetual Ocean if you want to find it. And I've also noticed it calms people down. Like sometimes if, the end of the semester, everybody's stressed out. So I'll play that in class and it just calms you down. So I'm going to answer some of these questions. Why are there so many swirling currents? Well, that is what our ocean looks like. The wind blows the surface of the water and it causes currents. And the biggest current is the Gulf Stream, which goes in the Atlantic from kind of Florida all the way up past New York and the East Coast up toward Greenland. So that's the largest. I know it is calming. That's the largest current. It's the strongest. Also, the Antarctic circumpolar current, the current that goes around Antarctica, is really strong. So I know I kind of want to play it again because it's so cool. But maybe if we have time at the end, we'll play it again. But again, the point that there's many points that I wanted you to see from that video. But one of the points is that I think sometimes people get caught up in their own local area. And when you work at NASA, you start to see that it's not us and them or anything. The whole world is our world. And the planet kind of looks small from space. And you see how the ocean, it brings the water from one area to the other. So something, that happens in one part of the world actually happens in the entire world. And it's because of the ocean connecting. You saw all those currents. That ocean connects the entire planet together. And you do feel kind of both small and large at the same time when you're looking at the ocean, when you're getting that global perspective from space. And there's the world again. So I want you to feel kind of in awe is what I feel when I look at that. And I also want you to feel empowered. There's so many things that you can do, even small things. And can you imagine if everybody joined together and took even small steps to make a difference, what it would do? And I think this next generation is called upon to do those things. So I kind of want to talk to you about some of the things you can do that can make a difference. And it starts with a story. So this is a sea slug. And I first started getting connected to science by sea slugs. Does the moon affect the ocean? No, the moon affects the tides. The moon affects the tides. So what affects the currents is the fact that the earth is spinning and the wind. And the moon is what affects the tides. Good question. Thank you. Okay, so I'm going to tell you the story of a sea slug. So when I was in high school, I wasn't particularly interested in science. And then I learned scuba diving. And I was taking a science class that was required, and I was really into scuba diving. And one time we started to study sea slugs. And I've been on lots of dives, and I passed through these sea slugs, and I never really seen them. And then we learned about them in class, and I started to see them everywhere. They're quite beautiful. They're really small. They're only about this big. This is a close-up of one. And I related to them because they seem so vulnerable. They don't have a shell, but they're poisonous. And they're really actually strong and amazing and interesting. And I related to them for that. And it kind of opened up my world for science, and it made me fall in love with science. And I guess what I'm asking you to do is to look in your life and find whatever that sea slug is. And you don't have to go to Mount Everest, or you don't have to go into space, or you don't have to go to the bottom of the ocean to find that one thing that connects you to planet Earth. And for me, I was, swimming past these sea slugs. And then one day I slowed down and I saw them and I fell in love with them. And I guess I'm asking you, what is it in your life that you're going past and not even seeing, that if you just kind of slow down a little bit and took a look, what would change your life and make you really open up and collect planet Earth? So I'm just going to look at this question here. If people don't change, how long do you think it will be until humans are extinct? That's an amazing question. And again, there's projections to how much the heat will rise if people don't change. But as far as becoming extinct, it's really hard to say exactly when and if humans are going to become extinct. I mean, we're such a robust species. Right now, we're hardly becoming extinct. We're actually increasing in population. We're over 7 billion people. So I don't mean to scare you and to say everybody's going to go extinct. I mean to empower you to say we can make a difference. That's what I'm hoping we're going to do. Certainly, and it's by, connecting with our planet and feeling empowered. And whether or not, and I ask you back, what's your sea slug moment? What's your moment where you're going to say, I love this planet so much that I'm going to make a difference with my life no matter what? So that's my question back to you. And a lot of it depends on us, and especially future generations. What are we going to do to make a difference? And, anything could change. We used to have, 100 years ago, there weren't cars, there was horses, and the horses would leave manure all in the streets. And, in New York City, people thought that, we were going to be eyeball high in horse manure because there were so many horse and carriages. And then all of a sudden, the horses were not polluting the streets because there were cars. So, one of you right now watching could invent the next, green technology. And then it's, game over for climate change, and we're moving into this new, really exciting world. So I want you to look at every challenge not as something negative, but an opportunity. Every challenge in your life. If you can take that home from this conversation, then I will feel like I've made a difference for you. Anyway, so that was my sea slug moment. And I think the first step for everybody, what can they do, is instead of feeling negative fear, try to find something that makes you feel awe and wonder, that makes you feel, I want to connect to planet Earth. Because when we're freaking out in fear or negativity, it makes us like turn away. And I want you to not turn away. I want you to face the challenges, because we all need to. So the first step is to face and connect to planet Earth. The second step is to connect with other people, and you can become empowered in groups. So this is a group of my students who are working together and never stop learning. And what that means is that, like at the school where I teach, there's a green club. At NASA where I work, there's an environmental club. And so there's communities all over this country and all over the world where people are coming together, and you can share things. So you can share education. You can share, well, I composted. Oh, I learned how to grow this crop. Oh, this is a better type of car. All kinds of things we can do in groups, and groups are more powerful than individuals. So yes, you can do things on your own, but you can also connect with the people in your community and become empowered. So how frustrating, difficult is it to persuade those who mistakenly believe global warming is a natural process of life are not real, especially when some of them. Okay, so I mean, yes, working on climate change, we have a Facebook page. We get tons of haters. I get tons of hater emails. To me, whenever I get a hater email or a hater comment on Facebook, it makes me feel like I'm doing something important, because if I was sitting in a corner not doing anything at all, I wouldn't have the haters. So despite the haters, you see improvement everywhere. You see, our fossil fuel usage in this country has gone down despite the fact that the economy has gone up. Solar power is increasing, wind power is increasing. And yeah, I think that the people who are denying climate change are fewer and fewer and fewer, and the people who believe in a new green, responsible economy are way overrunning and way dominating the conversation right now. So I think that in fact, you see people are not denying climate change as much as they're saying, oh, well, it's going to be too expensive, is the kind of talking point we're hearing now. But the reality is that it's going to be more expensive to deal with the damages than it is to prevent those damages. My puppy just woke up. Sorry, I got a little distracted there. So you might see a dog in 2 seconds run in front of the camera. Okay, so just to remind you, get together in groups. You're more powerful in teams than you are as individuals. And one of the things we've done at NASA, this happened all last year, we launched 5 new satellites. to study planet Earth and to keep moving forward. So this one's for precipitation. This one's for wind. This one is for small particles in the atmosphere. This one studies carbon dioxide, and this one studies moisture on planet Earth, and very specifically. So again, teams, groups, way more powerful than individuals. And you can learn from each other, you can support each other, and you can act. And then one of the things I also wanted to tell you is there's so much empowerment you can take by just appreciating what's in your own yard. And I put this sea snake in here to kind of represent what it's like to feel alone and to tell you that you are not alone when you're connecting with planet Earth. I think sometimes, we are over consumers because we want to like get more and more and more and more and more stuff. And it's to combat that feeling of being alone. But the truth is, when you're connecting with planet Earth, you are not alone. And I think this is the last slide I've got. So we've got a few more minutes for some questions, or we could go to my website if you want to look. So yeah, ask me some questions. I know I've been talking a lot about a whole bunch of different stuff, but do you have
I was going to jump in, Laura, and just say, first of all, thank you for this incredible presentation. And I just wanted to echo your sentiment of, it's really about the future generation taking action, and everything that everybody does makes a difference. And that's something that our co-founder and president, Philippe, always says. And so it's super important. And we have lots of resources on our website. I know there's resources on NASA's websites about what youth can do to take action and start now. You don't have to wait until you get older. Getting involved now in small ways can really help spark your interest and help you have a lifelong of green practices and that sort of thing. So we think that everybody should get involved now. I know that there was one question that came in a little bit earlier that just asked sort of like how you got into NASA, because it seems like you've done a lot of really great things in your life. So what sort of landed you at NASA? How did that path work out?
So I guess this is also a story of believing in yourself. So, and this is true. I know it sounds silly, but NASA's Jet Propulsion Laboratory is about a 10-minute drive from my house, and I knew I wanted to work in science, and I knew I didn't want to drive very far. I live in Los Angeles. So it took me about 3 years, and I knew I wanted to work in oceanography and climate change, and I just kind of kept banging on the door until they actually ended up making a job position just for me and then hiring me. So it's a story about believing in yourself and not giving up. And I guess that's the most important thing. I can't tell you how many times it's the most heartbreaking thing I hear when I tell people what I do for a living, and they go, oh, I used to like science when I was a kid, or oh, I'm not a science person. There is nobody who isn't a science person. Every little kid likes to dig in the dirt. Every little kid likes to play with rocks. Every little kid likes to play with leaves and, the natural world. And then somehow we forget that as we age and we start to feel bad about ourselves. Everybody who's curious about the way the world works is a scientist. So whether you get a job in a scientific lab, whether you get a job as a research scientist, or whether you just, end up being a person who enjoys science your whole life, you can participate. It doesn't mean anything. Everybody, the most smartest scientist who you could ever imagine in your life, had tons of obstacles and tons of failure. So it doesn't mean anything if you are, even if you're struggling a little bit. It just means cool, you're on the right path, because we all struggle. And if you're not struggling, good for you. Chances are the longer you work at something, the more struggle you'll have. It's just the way of life. And I want you to look at struggle as an awesome opportunity to say, game on, I got this, I can handle it, I'm a super strong person.
That's great advice that, you've really created your own path, and that's something that so many students can do, and everybody has a really unique opportunity today. With technology and the world changing so fast, I think that there's a lot of opportunity for for students to do that in their future careers as well. So I think that's a really great sentiment.
Absolutely. And I don't see my camera anymore, but hopefully you can hear me. I just want to add, a lot of students are super interested in what kind of jobs they can get, and people who have multiple skill sets tend to get more jobs. So you might have a little bit of a science background, but there's jobs as science writers, science video makers, photographers. My puppy's really making a lot of noise now. There's all the graphics, all the videos you've seen were done by people who had kind of science and art backgrounds together. So there's the umbrella over the opportunities to work in the science field is very, very broad. Certainly science teachers, science filmmakers, science website developers, science writers, science bloggers. So I just welcome you to participate. You guys want to see my puppy? Come here. Come on. Come on. Here's the puppy. I don't know if you can. Oh, he's really going crazy now. He just woke up. Can you see him on camera?
That's perfect.
Can you see my camera?
He looks great.
Yes.
Oh. Well, thank you so much. Right. I mean, I really think that everything you said is great. And science careers that aren't necessarily like a scientist in a lab aren't highlighted that often. And so it's been great to have you on here and talk a little bit about your work more as a science communicator and how there are so many multiple skill sets needed in all different types of science disciplines. So thank you so much for that. And with that, I think that is about all of our time today. So thank you so much for stopping by, and we will be following up with some emails to everyone who registered so that you'll be able to access the links and view the presentation afterwards, and some resources as well. Oh, one more question from Elgin before we sign off. It's coming in, they said.
Okay. Oh, now the cat and the dog are chasing each other. It's like chaos at my house.
Normally. See here, it looks like they're typing, so we'll get that.
One more question. All right. I look forward to it. And thank you guys for participating, for showing up. Does the water level raise this? No, it doesn't. So, and it changes. So remember, water's moving all around. Some areas, the land is sinking also, like Venice, the land is sinking. In California, the land is rising. So sea level rise is going to be variable depending on where you live. And if you want, I could probably take you to a website where it shows you different areas of sea level rise. But
why don't you, Laura, if you can email me that link, we'll send it out in the follow-up email as a resource. That way classrooms can really have time to explore that and look at what's sort of happening near them.
Exactly.
I think that would be.
Yeah, and you can see I have it's like a video where you see the sea level changing different areas in different parts of the world, different seasons also. Just like if you stood on the beach, sometimes there's high tide, sometimes there's low tide, there's waves, there's storm surge. Oh, by the way, your website is awesome. Thank you. We won 5 Webbies. Actually, you can see 2 of the Webbies are right there behind me. Webby Awards for Best Science Website. So thank you very much.
Very fun. Awesome. Well, again, thank you so much. And everybody have a great rest of your Friday. We hope to see you possibly for a couple more webinars today, but if not, have a great rest of your Friday. Thank you so much.
Thank